Hello, everybody. If I speak at this volume, can you hear me? That's all right? OK, cool. So I've got like 16 minutes, so let's pick this up. Hands up if you've ever heard of SketchUp before. Yeah? Hands up if you're a SketchUp user. A few people. All right, so blank out the first couple of minutes of this because it may be sort of basic, but here's the deal. SketchUp is free 3D modeling software from Google. The backstory is this. About 12 years ago, it was really hard to make 3D models for movies, for geographic visualization, for anything. You needed like thousands of dollars worth of software, and you needed like hundreds of hours of training, and it was miserable. Really, the only people who could do it were students and software pirates. Those are the people who used this stuff. And then somebody had an idea to say, well, actually one of our founders, why don't we make a new piece of 3D modeling software that's super easy to use based on the idea that you can draw things in 2 dimensions, right? Hands up if you can draw in 2 dimensions. Sort of, right? Everybody's familiar with the concept of the paper and the pencil, right? But what if you could do that, and then you could turn something into 3 dimensions by just using this like magic tool on it? And we've got this tool. It's called the push-pull tool, but I'm sort of jumping ahead a little bit. Let me close this. I'm closing up toolbars. This is what SketchUp looks like when you download it. Who's this little person in the middle? Anybody know? 50 points if you know her name. Her name is Susan. We choose a different person from the SketchUp team every time we create a new release. So if you're using SketchUp and you see a Korean guy named Sang or a white hipster guy named Bryce, you're using old SketchUp. You should download new SketchUp. New SketchUp, SketchUp 8 has Susan in it. Now we're going to do, well, in a second we're going to do what everybody does, but watch this. Why do you think we have Susan in the middle of all of our modeling environments? Why do you always start out with Susan? Scale, that's exactly it, right? So if I take a rectangle like this, and I draw a little rectangle on the ground, something like this, you can see that that's sort of like a tiger prison for Susan. But if I went like this, that's like a McMansion for Susan, or if I zoom way out, I can do something like a shopping mall for Susan. So one of the hardest parts when people are starting out with 3D software is getting the notion of scale and measurement. What we do is we put a little scale person in there so that it's really easy for even like rote beginners to jump in and figure out exactly where they are in the software. What are we going to do with Susan now? What's the most popular thing to do with Susan? We're going to delete her. That's what we do. OK, so that said, you should say like thousands upon thousands. We have millions of users, thousands of models with Susan standing there. She's just so popular. It's so depressing. Anyway, so why do you think we have in this, uh-oh, I'm lost in my modeling environment. I don't know what's going on. All right, if this happens to you, it's very easy. You just close, don't save, and open a new file. And then there's Susan again. All right, 1, 2, 3. Bye, Susan. Ready? OK, we go. These are the modeling axes, these colored things. Why do you think they're colored? Anybody? Hands up. God, it's like kindergarten. Up like this. Hands up. Anybody have an idea? Why are they colored? Yeah. So you can keep track of when you rotate. That's a good one, especially when there's nothing else in the model. Here's the problem with 3D modeling software. We're trying to create a 3D model on a 2-dimensional screen. Does that make sense? Right? This is a 2-dimensional projection. So if I put Susan back like this, and I put my cursor right here, where is my cursor in 3-dimensional space right now? It's next to Susan's head, right? Or is it 50 feet behind Susan's head? Or is it 50 feet in front of Susan's head? You don't know, right? Because this is 3-dimensional space represented on a 2-dimensional plane. How are we supposed to know if any point on that 2-dimensional plane represents any one of a billion, let's say more than a billion, right? Like an infinite number of 3-dimensional positions. Is this making sense? OK, so what we needed to do was come up with a way for a person to tell SketchUp, tell the computer where they mean to be in 3-dimensional space without having to do a lot of typing and nerdy stuff. So watch. If I take this pencil and I just start to draw on the ground, the very first assumption that happens in SketchUp is when I just draw on nothing, I'm drawing on the ground. So see, I just made a little polygon, just like that. But most of the time, people want to draw parallel to one of these orthogonal axes. Does that make sense? Right? Like if you're an architect, engineer, a lot of the time, we live in sort of a 90-degree world. There's a lot of 90-degree angles in this room. It's depressing, but that's just how things work. It's how tools are made. Go to Home Depot. It's a 90-degree universe. So watch. If I go like this, and I start to draw a line, and I want it to be parallel to that red axis, what color is the line going to turn? Red, exactly. OK, red. Let's go green, red, green, back in the red, and then back in the green. And what I've done is I've drawn an L shape with perfect 90-degree angles without having to type anything in. So if you leave now, if you remember nothing else from today, but you want to use SketchUp, you load it up. Color is direction, okay? That's the single most important thing you can remember when you're trying to learn how to use software like this, is color is direction in SketchUp. So if I want to draw a wall that's perpendicular to this floor plane, and I want to go up like this, I'm going to go blue, right? Because blue is parallel to the vertical direction. Let's go red. Back down in the blue, now I've drawn a wall that's just like that. Watch what happens if I don't follow the colors, right? I'm going to say, you know what, I went to architecture school. I can totally do this. SketchUp is forcing me to do things here because it's smart. Google's such arrogance. OK, and I'm going to draw this thing. But watch, it didn't close in. Why didn't it close in? Because it didn't draw what I thought I was drawing. It's really important to follow the colors. OK, here's this tool. This tool is called the, anybody SketchUp people? SketchUp people, please, my people. What are you called? What's that tool called? It's the push-pull tool, right? So this is the tool we actually got the patent on, and everybody has subsequently stolen it, and we don't enforce our patents because, you know, SketchUp is a very tiny piece of Google, very tiny. We're much more interested in phone companies. OK, so here it goes like this. We're going to go push-pull. Watch, I'm going to click on this face. Remember how I said before it's about drawing two-dimensional shapes and then pulling them into 3D? I'm going to go click, and then that's 3D, just like that. So now all of a sudden, if it's a 3D figure, if I click on this and delete it, you'll see Susan's still hiding inside. Hello, Susan. Uh-oh, we're going to put her back in the box. Watch this. If I go like this and I offset a little three-dimensional wall, and then I push this down all the way to the ground, now I've got a thick wall. And if I want to give Susan some air, maybe, let's just put a rectangle on the wall and push this back. And now I've cut a hole through there, just like that. If I take the arc tool and maybe just draw a little arc on here, and want to push this back to there. See, when you push back from one face to another, it automatically gets rid of the face that you pushed back into. And that's the modeling paradigm in SketchUp. There's all kinds of incredibly whiz-bang, super cool stuff you can do with this program, but I don't have time to show it to you. So instead, what I'm going to do is I'm going to show you my new house in Boulder, because this is the sort of huge nerd I am. Before we even bought it, before I made an offer, I went around and measured it and built a 3D model of it. Because I wanted to be able to do, because you know, this is what I do and I need new fodder for demos. But basically, this is the house, right? Now we have this feature in SketchUp called shadows. And if I turn on shadows, check it out. When I change the time of day, or I change the date, that shadow is actually going to change. Now, is that shadow accurate? Hands up if you think it's accurate. Hands up if you don't think it's accurate. Hands up if you think it depends. Yeah, it depends. So what does it depend on? In order to get an accurate shadow, you need to have 4 things. You need to have the time of day, you need to have the day of the year, and you need 2 more things. What are the other 2 things? Hands up. Yes. Location, right? And what else? Elevation. You don't really need elevation for solar stuff. What else? I'm sorry? Intensity of light source. You're a big nerd. No, we're not doing that. That's for rendering. This is more like just shadow positioning. What you need to know is where north is, right? Where's north? So in SketchUp, here's the deal. By default, if you have not geolocated your model yet, green is north. Make sense? And where are we on Earth? Where do you think a Boulder-based company would have made the default location for everybody in the whole world? Boulder, exactly. And you can pretend it's Fort Collins if you want. You'll just be off by a couple inches. It's fine. In fact, that's a good slogan for Fort Collins, off by a couple inches from Boulder. OK, so we're going to go like this. So if I change the shadows around like that, right, that's the shadows moving. So watch, if I go back over to my house and I want to see so what I actually was interested in was, if I ever sit on my front porch, am I ever going to get any sunlight? So if I go to set this to summertime, and I change this, I can actually see how the shadow's moving across that porch. It looks like if I get up really early in the morning, 4:49 like that, and not really, and then in the evening, is it ever going to go? No, that's a permanently dark spot. Don't put the herb garden there. But on the back, I can totally do it, right? So you can see the implications for anybody from architects, landscape architects, anybody who needs this kind of shadow study. I showed you that because I think it's incredibly sexy and cool, and that's really important. Okay, this thing here is just a piece of the Earth from Earth. I don't have a lot of time, so I'm going to show you how to do this now. I was doing a demo last week for NBC News. So we work with all the broadcasters in New York and around the world to use Google Earth and ancillary products to build models for breaking news. And the nutter in California had just shot those people at Oikos University. And so what we did is we actually, in 10 minutes, built a model of that building using resources that you can get for free on Google. But we're not going to do that. We're going to do something else. So name out a location. Shout something out. Timbuktu. Oh, another place. There's no ever any good news like this. Timbuktu is under siege right now, isn't it? Look at that. We have really good aerial imagery for Timbuktu. All right, so what should we model? Let's build them a new monument. Let's go over here like that. This looks like a godforsaken place, so we'll put it there. I'm going to say, you know what? I want to build something right there. I'm going to select a region. It's going to let me grab a piece of the Earth right here in SketchUp. And I'm going to say grab. And then look, there's Susan. Ah, duck! Let's delete her so she's safe. Okay, good. So we'll do that. And what did I get when I hit that little maps embed? I got aerial photography in color. I got north orientation. You saw how small Susan was, right? So it actually came into scale. And if I hit this button, you'll see I'm actually getting three-dimensional terrain as well. Not very impressive in Timbuktu, or at least this part, but you get the idea. And check it out. If I come in here and I want to build something like, I don't know, a bunker, or something like this, I don't know, something like that. Let's go up here. I'm going to, oops, let's come up here and flare this out, and maybe go like that. Ooh, cool. All right, so we can go in and maybe push this down, and then I can come in here to my hidden geometry, and I'm going to go like that. So you get the idea, right, what I'm doing here? I'm just going to kind of push this down. If I went along with this, I could make like a crenellated turret that you could say, save your life from. Do something like that. That's pretty nice. And then I'm going to paint it a meaningful color, something inconspicuous that you wouldn't be able to see. Ba-ba-ba. All right, nothing to see here. We've got a little turret. And I want to see what that looks like in Google Earth. Is there a button up here? It looks like it might help with that. Check it out. What it did is it just exported a 3D model in Collada format. Hands up if you've ever used Collada before. So Collada is an up-and-coming new 3D file format that's been up-and-coming for like 10 years. The problem with 3D modeling is there's no such thing as like JPEG. There's no common universal file format for exchanging files. So every 3D modeling program has its own thing, and file exchange actually becomes a really big deal. But check it out. This is Google Earth. I just pressed that button and I loaded up Google Earth. This is Timbuktu in Google Earth, and there's the 3D model I just built sitting right there in Earth. Hands up if you think that everybody with Google Earth is looking at this right now. No. Okay, good. Excellent. It's actually just a file that's sitting on my computer. Now, there's this whole thing I don't have time to show you, but it's called the 3D Warehouse. The Google 3D Warehouse is like YouTube for models. It's this huge repository of 3D models that anybody in the world can go to. See? Okay, name something esoteric I can look for. What's that? Pyramids. Pyramids. Check it out. There's some models of pyramids. If you see this little icon, that means it's a model that actually also exists in Google Earth. What else should we look for? Skyscrapers. Let's think more out of the box than just buildings. What else can we think? Like teapot. Oh, you're a 3D Studio Max user, aren't you? Teapots. Okay, there's a teapot right there. So you get the idea, right? Anything we type in, it's using Google search. There's this huge pile of 3D models. So you can combine stuff other people have made with your stuff. And if you like your stuff and you want to share it, you can upload it and share it with them too. I think my time is up, but there's going to be a Q&A session at the end, right, where I can show you this. All you have to do is go to sketchup.google.com, or just search for SketchUp on Google, even Bing. You could search on Bing if you want. And then you can download SketchUp. There's a free version, and there is a commercial version. Normally that costs $500, but faculty get it for free. They can share their free pro version with their students. And students, if they want to buy their own pro version, get it for $49 a year. OK? Cool. Thanks very much.